Let's create a timer variable and a new method called initializeGhostTimer, and then we'll see. Our code is where the ghosts come to life. It's time to introduce the ghost timer, the engine that keeps those pesky ghosts moving around and making Pacman's life a whole lot harder. Let's dive in. This method is like the ghost factory. Here's where we set the gears in motion for those little terrors. We create a new timer object, the backbone of our ghost movement system. Think of it as a ticking clock that tells the ghosts when it's time to take a step. Here's the pace. The interval is set to 500 milliseconds, which means the timer ticks twice a second. Every tick is a chance for the ghost to creep closer to Pacman. Adjust this interval, and you'll make the ghosts move slower or faster. Perfect for tweaking the game's difficulty. This line hooks the timer to an event handler. In simple terms, every time the timer ticks, the code says, "Hey, run the ghost timer_tick method now." It's like ringing a bell that wakes the ghosts up. And here we flip the switch. This starts the timer and sets the ghosts in motion. No going back now. It's ghost party time. Ghost timer tick is an event handler. It gets triggered automatically by the timer, kind of like an alarm clock going off every half second. Move ghosts. This is the key line here. Every tick of the timer calls the move ghosts method, which contains the logic for making the ghosts shuffle around the game board. Without this, the ghosts would just sit still, totally ruining the suspense. This system is what keeps the game dynamic and exciting. It ensures the ghosts aren't just static obstacles but active, menacing threats that follow their own rhythm. Alright, it's time to dive into one of the most exciting parts of the game, moving the ghosts. This method gives the ghosts their unpredictability and keeps players on their toes. Let's break this down step by step. We start by creating a random object. Why? Because ghost movement needs to feel unpredictable. Imagine if they followed a fixed path, it wouldn't be nearly as fun or challenging. With this randomizer, we give the ghosts a mind of their own. This is our temporary memory bank to store the new positions of the ghosts after they move. It keeps things clean and organized as we calculate their next steps. Here, we loop through each ghost's current position. It's like saying, alright, ghost number 1, what's your next move? Ghost number 2, you're up next. This ensures all ghosts get a chance to shuffle around during each timer tick. We create a copy of the ghost's current position. This way, we can calculate its next step without immediately overwriting the original position. The random next 4 generates a number between 0 and 3. Each number corresponds to a direction. 0 equals move up. 1 equals move down. 2 equals move left. 3 equals move right. Basically, every ghost rolls a digital dice to decide where to move next. It's chaos, but it's fun chaos. Now, we update the ghost's position based on the random direction. If the dice rolls 0, the ghost moves up by decreasing its Y value. If it's 1, it moves down by increasing its Y value. 2 makes it go left, and 3 sends it right. Simple, but effective. Here's the fun part, can the ghost actually move to its new position? Is walkable new position. This checks if the new position is valid. No walking through walls or other obstacles. If walkable, the ghost moves to the new position, and we store that in new ghost positions. We redraw the ghosts on the board with redraw ghosts. Finally, we mark the new position on the level grid as a ghost tile, G. If it's not walkable, the ghost stays put, and we just add its current position back into the list. No cheating for these ghosts. Why this matters? This whole method adds the dynamic element of uncertainty. Ghosts don't just sit still, they roam around the map unpredictably, making the game much more thrilling. It balances simplicity, a dice roll for movement, with strategy, only moving if it's allowed. This randomness keeps players on edge, especially when ghosts start closing in on Pacman. Move Ghosts is the brain behind ghost movement, ensuring every ghost gets a random new position. It calculates the moves, checks if they're valid, and updates the board accordingly. This method gives the game that classic, suspenseful Pacman feel where you're always one step away from danger. However, there is still something missing in the method, and we still have to fill the redraw ghost method with code before we can test it. So let's get started. Let's finish up the ghost movement logic and explore how we bring these spooky creatures back to life visually on the game board. This is where everything comes together. This line right here is the grand finale for ghost movement. Once we've calculated where each ghost wants to go and verified that the positions are walkable, we update our main list, ghost positions, with the shiny new positions from new ghost positions. Think of it like this, the ghosts were planning their moves in a temporary draft, and now we're publishing their final positions into the official game board. And now, the magic moment, we call the redraw ghosts method. This method ensures that the new ghost positions are actually visible on the game screen. Moving in silence is no fun, let's make sure the ghosts show off their spooky moves. We loop through every ghost's updated position. It's like saying, okay, ghost number 1, where are you now? Ghost number 2, let's update you next. For each ghost, we call the update tile method to refresh its visual representation on the game board. It's like putting on a fresh coat of paint for the ghost's new spot. Redrawing is a critical step in game development. Without this method, your ghosts might move around in the game's logic, But the player would never see it. Talk about frustrating. By redrawing, we synchronize the game's internal state, where the ghosts are, with what the player sees on their screen. This creates a seamless and immersive experience. Oh yes, that looks quite different now. The ghosts move through the labyrinth and find their way at random. Perfect.